In this video, we're going to look at the problem: a ball travels along a horizontal surface at 3 meters per second in the positive x direction. It has a mass of 5 kilograms. A second ball, a mass 6 kilograms, travels at 4 meters per second in the negative x direction. The two balls have a head-on elastic collision. What is the velocity of each ball after the collision? Alright, since we're using a collision in this particular problem, that tells us it is a conservation of momentum problem. And since it specifies that it is a elastic collision, that means we can use our equations that only work for elastic collisions. And that's good because we have two unknowns. So our goal here is to find the final velocity of each ball. So we're trying to find V1 final and V2 final. Alright, so let's start with conservation of momentum. So we have M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. And I'm going to start plugging in my information. Alright, so the first mass is our 5 kilograms. And that velocity is 3 meters per second. And then our second mass is 6 kilograms. And our second initial velocity is 4, but we have to be careful, it's in the negative x direction, so it's going to be minus 4 meters per second. Alright, so our first mass is 5 kilograms. V1F is an unknown. Second mass is 6 kilograms. And V2F is an unknown. Alright, I have two unknowns, but luckily I have another equation I can use, but I'm going to reduce this equation down as much as possible first. So you can see here I've rearranged the equation to solve for V2F in terms of V1F. Now let's turn to our second option for our elastic collision. So we're going to use V1 initial minus V2 initial equals a negative times the quantity V1F minus V2F. Alright, so V1 initial is 3 meters per second minus a negative 4 meters per second. And I'm going to distribute this minus sign in here. Alright, so on the left side I get 7 because minus a negative becomes a positive. Alright, so now I can take and sub this in for here. So I'm going to do 7 meters per second equals a negative V1F plus a negative 9 kilogram meters per second minus the 5 kilograms V1F, and this entire quantity is divided by 6 kilograms. Alright, so you should notice here that we only have one unknown, the V1F now, which means all I have to do is isolate the V1F. So let me do that. Alright, so we can see here that V1F equals a negative 4.67, which we then can take and plug in back up here. So we get a negative 9 kilograms times meters per second minus 5 kilograms times a negative 4.67 meters per second divided by 6 kilograms will give us our V2F. So that means our final velocity for the second object is 2.39 meters per second.